Okay, so establish a trig identity. Just two more problems I thought I'd show you. Remember that when you're establishing a trig identity or verifying a trig identity, that it's a left-hand side proof. That is to say, you're not allowed to touch the right-hand side. So I looked at this a little bit. I realized this thing has to go to, it says this thing has to go to 2. So what I'm going to do is I'm going to go ahead and expand this. I'm going to FOIL this out. And when I did, I got sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. Yeah? So that's this left-hand side. That's this part right here. That's the expansion of this. Now what I'm going to do is I'm going to go ahead and I'm going to expand out this side right here. And I think that goes to sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. And remember, this all has to equal 2. This 2 is this 2. All right? So now what I'm going to do here is I'm just going to simplify. I have 2 sine theta cosine theta here. I have negative that thing here, right? Have sine squared theta here and another sine squared theta here, which gives us 2 sine squared thetas, right? Plus we have, so I use that one and that one. Now we have 2 cosine squared thetas, so I'm going to use both of those, plus 2 cosine squared thetas. And remember that we're trying to prove that that equals 2, so there's that. Now what I'm going to do here is take the greatest common factor out, which is 2. So 2 times sine squared theta plus cosine squared theta. Remember, must equal 2. This 2 is still that 2. We know from our Pythagorean identities that sine squared theta plus cosine squared theta is equal to 1. So we have 2 times 1 is equal to 2, and that is true. All right, so that's how I would have done that problem. Here's the other problem I wanted to go through a little bit today. And what am I going to do with this mess? Oh, I know what I'm going to do. I'm going to use Pythagorean identities, and I'm going to take tan squared theta, and we know that tan theta is the same as sine theta over cosine theta, right? So tan squared theta is the same as sine squared theta over cosine squared theta. So that's me replacing my tan value. I'm going to keep this cosine squared theta, so it's cosine squared theta. Plus, we know that cotan theta is cosine squared theta over sine squared theta, right? So that's me giving the replacement value for this. And then I'm going to multiply it by this sine squared theta, and remember, it must go to a value of 1. Well, if you look here, we have a numerator of cosine squared theta against the denominator of cosine squared theta. That goes to 1. So when I multiply this, we just get sine squared theta, don't we? Same thing happens here. This side and this side cancel each other, so we get cosine squared theta is equal to 1. And your professor will really appreciate you saying this is true, because this is a, and I would use this, I would say this is a Pythagorean identity. Alright, so we have proof. I hope this was really helpful. If you haven't already subscribed, please do subscribe. If you have any comments, please make them. Appreciate it, you guys.